Next is a photovoltaic simulation machine that we use in this experiment. This is the photovoltaic simulation program. So you can program the irradiance profile. That's the left picture. And next, according to the experiment, we use buck boost converter to control PV's output voltage as maximum power point. And we use other experiment. Load is battery, source is PV, and switching power supply, and oscilloscope. As manual, we use buck boost converter to control output voltage by adjusting duty ratio. And the result is show it. This picture is represents result of experiment.
Next, in automatic, we're using DSP instead of switching power supply and using PSIM to generate code for DSP. This is DSP and buck boost converter. To using PSIM to generate code for DSP, we have to draw the diagram like this. And the diagram shows that we measure voltage and current to calculate power and hold it for to be power in the past and power in the present. And we compare it for decide with the duty ratio that we compare it. And we use different of power and different of duty to use to adjust duty ratio. And then we use exclusive NOR to compare them. When power is increasing, when duty is increasing and power is increasing, we have to increase duty more. If power is decreasing and duty is increasing, we have to decrease duty, so we have to use exclusive NOR. And then we generate code like this and open it in Code Composer Studio or CCS and debug it to DSP. You can see the result like manual adjust like this. This is result conclusion table. You will see that when light intensity is increasing, we have to increase duty ratio. And if temperature is increasing, we have to increase duty ratio too. For conclusion, tagging maximum power point, we have to adjust duty ratio to make output voltage at maximum power point. And to tag maximum power point by DSP, we have to using duty ratio and power to decide to adjust new duty ratio. Thank you for your attention. Are there any questions?
Too many questions. Okay. 10 นาทีพอดี
อันนี้อันนี้แค่5 นาที
ไม่มันหลุดไปแล้วไง
Okay. So let's move to your first slide. Second.
เสียงอะไรอ่ะ
เสียงเอฟเฟกต์
ทำไมต้องมีเสียงเอฟเฟกต์อ่ะ
เสียงอาร์ตเสียงอาร์
Okay.
ต
Your title is Box Boost Converter for PVS 125 Tracking. I think your experiment do not do the boost converter, only box converter. So it's better to change your title into box converter.
จะได้คำถามอาจารย์ว่า
Because we did not solder the another MOS FET in the circuit, so it cannot be boost converter. Just a box converter. Okay. And let's go to the next slide. Instead of your problem should be in plural. Problem. You have 3 problems, not 1 problem. Also, but also you choose like make some like the purpose or the objective of your experiment in doing the laboratory experiment. What is the objective? So you should state clearly about the objective of the experiment. I suggest first of all you because you have already studied power electronics and also you have experiment with buck converter in your 3rd year. Yeah. Okay. You will apply the knowledge of power electronics and buck converter into this experiment. And use buck converter with the solar cell or photovoltaic panel. So the objective, the buck converter is not the objective of your experiment, but the objective is you have to experience how to make buck converter yourself in the circuit. Yeah. Okay. And also about the PV characteristic, the IV curve, the effect of the temperature, irradiance to the output of the PV. And then when you want to extract or you want to output as much as possible the power from the PV to the load, you have to do something about the VI curve or PV curve. That is mentioned about the NPPT also. And then another objective is about to learn about NPPT algorithm. You apply in the DSP also. So there is many objectives in the experiment. The PV characteristic first, the MPP algorithm, and the apply of the DSP for to control the buck converter for MPPT. So this is the main objective of the experiment. So we should write the objective in
straight line
mm,
vertical
and we have many objectives. So this is the plural objective. Okay. Okay. To the next slide. And you have to state what component or equipment used in your experiment or the equipment you use in the experiment. Yeah. You have a buck converter, and what you have done with the buck converter, you have to solder yourself, you have to wiring the inductor. So that is a part of the experiment. So please improve that statement. And this is not a buck boost converter. This is we don't use this circuit. Okay.
Okay.
We don't use this circuit. We use the buck converter, not this circuit. Yeah. Okay. And this is yeah.
รู้สึกไงบ้างคะฟังพรีเซนต์
Very good.
We only do buck converter. Okay. No buck boost converter at all.
อุ้ยรู้สึกยังไงบ้างคะฟังพรีเซนต์
And you have to explain
Let's see,
more
huh?
about the basic of the buck converter. At the assumption of your buck converter, you want to operate it in the CCM mode. Yeah, and the switching frequency you use in the experiment, the size of the reactor, the inductor, the capacitor, the input voltage, and the output voltage, what is your load. So it should say very clear in your equipment, in your experiment, list of the equipment. Okay. Okay. This is a circuit for buck converter, so you have to use the schematic that represent this circuit. When you put the curve here, you have to. I think it will be better to put more curve in the graph in various conditions like this is only one condition, one gradient, one temperature. If you can show more conditions, for example, like the ingredients for 1000 watts per square meter, 500 watts per square meter, the temperature like 25 degree, 40 degree, 75 degree, and you can see the change in the maximum power point. So then you can conclude that if you want to extract the maximum power from the PV, what you have to do, you have to track the maximum power point, and then you can connect to the next presentation about the maximum power point and how you can achieve the maximum power point tracking in the buck converter. You have to adjust the duty of your buck converter. So you have to make a link between each slide. Make a link between each slide. So how can you go from this point to this point when we use DC-DC converter. When, for example, your output voltage is constant, like a battery. In this case, like a battery. But the operating point for the maximum power is changed. The maximum voltage, the voltage as maximum power point is changed. So how you can match the load voltage and the PV voltage, so that the output voltage, output power is maximum. How can you do
แก
that?
นะ
You
Can
have
I
to
get one?
change the duty ratio according to the operating condition of the PV. So you have to make connection. To the next slide. So why we use PV simulator instead of the real PV? Why you use? Because the teacher say so.
เขินเลยเขินเลย
We cannot use PV to see how different from when light intensity is high or temperature is high. We cannot control that. We have to use simulator.
So and the title should be photovoltaic simulator. Huh? Not power photovoltaic simulation. Okay. And it would be better that you have some spec of this equipment. If you don't know, it's okay. I don't know. But if you know, please. The next. And this is a PV simulator that's interface with that PV simulator. This is the software. And also to the software, how do you know that right now it's in the maximum power? If you want the audience to understand that now it's operates in the maximum power point.
At the vertical bar at the right side of the presentation, you see that MPPT.
So maybe you can include the arrow sign or some graphic in the slide to guide the audience that if you want to look at this, it is operates at the maximum power point, where should you look to? Okay, it should be easy for the professor to understand what you want to say. Okay, yeah, this should be like the experiment setup. The title of your slide, the experiment setup, and it should explain this part. So this is a manually control, or you can like the manual control. You can adjust the ratio by adjust the potentiometer. Hello,ครับ ฮัลโหลโทรหาใครครับ
อันนี้เป็นเด็ก
เวนรู้สึกช่วงนี้โทรผิดบ่อยจังเลย
เขาโทรหาหมอน้า
อืม
พี่ยาม่านะ
มีคนมาโทรมาสั่งปลาสลิดกับผม ผมจะให้เบอร์ฟิลไปแล้วเนี่ย
ไอ้อันนั้นสั่ง
โทรภาษาใต้มาเลยครับเอาว่าไงนะแบบพูดภาษาใต้มา
Well, you have to explain more in this slide, not just show the picture. Nobody can understand what you want to say. What is a yellow dress, green dress, and what you expect the audience or the professor to see in this slide? The duty. You see the duty of you just see the duty of the dress yellow, the yellow one, not the green one. Yes. And at this duty, you have to show that it's already operate in the maximum PowerPoint, highlight the bar graph or the MPT percent, and also please show that the output power P MPT that you get. And also please explain more about the PV, the condition. The yellow line and the purple line. What is the yellow line mean and the purple line? You can use the arrow key, arrow and number. Next slide. And not the result, that return with the experiment result. Experiment result. And the result should in plural. So when you say that this is an automatic MPPT and you use the DSP instead of you use the DSP instead of not. You also still use the buck converter. You also use the buck converter, but you vary the duty ratio automatically using the DSP. Yeah. There still you have everything is the same with the manual experiment, but you just adjust the duty ratio using the DSP. And also you program the DSP by via the PSIM using the schematic diagram. And good. Don't forget about the buck boost converter. Instead of this one, you should have like a MPPT algorithm, maybe like a flow chart of the MPPT. This is the method called P&O or mountain climbing algorithm. So you just look into the reference of any books about P&O, perturb and observe, and then you can explain. You implement in the PC. So some professor may ask you, did you program it yourself? You have to make some understanding of this thing. And it will be helpful if you have to add like a process to use PSIM with the DSP. Like you have to write the program like this in the PSIM, then you generate the code for the CCS, and then you compile the code in the CCS, then download to the DSP, so you can show a little bit. Okay, next. This is a code that generates from PC for the CCS. Next. What is this? When you import into the CCS. And this is like the same picture I saw you. Oh, it's not good. Please use another picture. You have should be a different experiment condition. This is even the number is the same with the last one. It's not good. Return. This is not light intensity. This is like a irradiance in the watt per square meter. Irradiance level or something. Not the light intensity. Light intensity has different unit. It never measure in watt. Light intensity, you have to wait with the wavelength, so it can change into watt. So it means nothing in your experiment. Light intensity should change into more understandable irradiance in the watt per square meter. And you have the duty ratio at the MPP. And do you have like for example, you have the theoretical value, and you have the value that you obtain from the experiment. You return to the slide, the last slide. This one. So you have like a yellow line and purple line. At each point, it should have like a theoretical value for the maximum power. And when you operate with the buck converter, then you have the power by manually adjust or the DSP, and you have the duty ratio and the maximum power. You choose compare the true theoretical power and the power that you obtain from the maximum power tracking. Right? So and put it in the table. Here, like this. And you have this from the manually adjust or use the DSP.
Using manually adjust.
Which one? So you just want to show only that is okay. You just want to show only the DSP is okay. The result from the DSP only is okay. So I'm not serious with the manually adjust. But please include another information in the chat. Okay. The conclusions. And please change the conclusion. Yeah. The conclusion should be what is the assumption in your experiment and what do you get after you did the experiment. That's the theory and practice agree well. Or what is the problem that the experiment value and the theoretical value that's or anything. And also, what have you learned in the laboratory? Okay. Okay. So now the question from the audience. One group, one question.
โครงการรัฐบาลเลยมีกลุ่มเป็นคนทำ
โอเคฟิลเป็นตัวแทนกลุ่ม
ถามค่ะ ถามสิคะ มีคำถามไหมคะ
ภาษาไทย
ภาษาอังกฤษ
อ๋อ
เราเลยนะจะได้ไม่ต้องมี
เราจับผิดไวยากรณ์นะ
นึกคำยังไม่ออกเลยถามสิคะ เดี๋ยวมันนึงอย่าเพิ่ง